Hi, this is Understanding Windows Lateral Movements Part 2. In this video, we are going to continue with user impersonation. So user impersonation is the act of acquiring the security context of another user in order to act on its behalf in the network. We can use that security context to move laterally or enumerate stuff remotely or whatever. So we can either create a new security context belonging to that user or hijack an existing security context, okay? If we want to create a new security context, we commonly require credentials. Whereas if we want to hijack an existing security context, we require privileges. We will be focusing on using all the Windows components we've been studying in the previous video, APs, logon sessions, and so on. But we will also show alternative ways to perform user impersonation without those components. So the following slides, we are going to see impersonation via access token manipulation, passwords, anti-hashes, and Kerberos tickets. But bear in mind that other types of credentials and protocols exist. So something like this. If we have passwords, we can essentially authenticate into other systems and services. So we can create a security context. On the other hand, if we have a hash, Windows doesn't support the use of hashes for authentication. So we need to do some tricks to achieve impersonation and authentication through a hash. For tickets, we can import, Windows supports different functionality to import Kerberos tickets in LSA. So we will see different ways to leverage a Kerberos ticket to impersonate users and do stuff. And finally, if we happen to compromise a computer and one user is working there, we will find processes and tokens from that user. So if we have enough privileges, we will be able to manipulate existing tokens from that system. And essentially, we can hijack the security context of that user and use it to access remote resources. So we are going to start with tokens because this one is going to be useful for the next sections, okay? So the most important thing here is to remember that an access token is just an object that represents the local security context of an authenticated user. Okay, if we want to use a token to move laterally or to access remote resources, we are going to need that token has a linked logon session with cached credentials, because cached credentials can be seen as the network security context of a process. Okay. So the Windows API provides functionality to manipulate access tokens. Okay, we can use legitimate functions to duplicate tokens, to create new processes with a token, and so on. But of course, depending what you are trying to do, you will probably require privileges. If you want to steal stuff from other users, you will typically require a high integrity process. Okay, so if you are a system or you are a local admin, you will be able to do anything. If you are a service account, you will likely have privileges like say impersonate privilege, and you will be able to use techniques like hot potato, juicy potato, and the like. Finally, if you are a normal user or a low privilege user, you are not going to be able to manipulate stuff from other users, but you will be able to manipulate your own stuff, your own processes, your own tokens, and so on. Okay, And we will see more about this in later slides. So access token manipulation is for hijacking a security context, okay? So there are two common approaches for this. We have the token impersonation approach or token stealing and the process injection. Token impersonation, let's imagine we have compromised a system and the Bulma user, domain administrator user, is working there. So we will spot processes from Bulma. Those processes will have a token belonging to Bulma and a logon session, a linked logon session that, well, hopefully will have cached credentials. So with this technique, we are going to open the target process. We are going to duplicate the token and we are going to use it on a new process or an existing thread. Okay, let's see a quick demo of this. So we are in web 01. We're going to get Meterpreter session. And here we have a process running as Bulma. Okay. So session number 6, we are Vegeta. We are in a high integrity context. And if we enumerate processes, we can spot this process belonging to Bulma. Okay, so token impersonation is implemented in Meterpreter through the steal token command. We just need to specify a PID and that's it. What it's going to do is open the process, get the token, apply it to our current process, and we will acquire the new security context. Okay? So stolen token with username VulmaDA. If we run getUID, VulmaDA. If we create a new process, that process will be created with such token. So here, who am I? It is going to show Bulma as well. I'm not sure why it's so slow, but it should show Bulma. All right. Okay, so if we do a quick check in Meterpreter's code, here this functionality is implemented in the STD API extension. Here's the function, steal token. So yeah, we can see that the target process is opened, gets the token here in H token, and then uses the impersonate logged on user function to kind of apply that token to the current thread, to the running, to the thread where the Meterpreter session is running. But if we see here, it also duplicates that token, okay, H token into H dup token, and that one, it saves it for later usage. So when we create a new process, Meterpreter checks if there is any saved token, and if so, it uses it to create that process. Okay, so that's why when we specify cell, by default uses thread impersonation, so it uses the saved token, and that's why it's running as VulmaDA. Okay. On the other hand, we have process injection. So here we are essentially just, if we have enough writes, we can open the process, we can write our capability or our payload and execute it. So the payload is going to run with the desired security context. Okay, so essentially if we come back to the original state with rect to self, we are again Vegeta. And Meterpreter implements process injection with the migrate command. Okay, so migrate, we can specify the PID once again. It's going to take some seconds because my Meterpreter is the slowest one on the herb. And now, if we get the PID, we are here. Get UID, we are Bulma. And cell, we are Bulma as well. Okay. So I want to begin this section talking about the runas program. Runas.exe is a program in Windows that allows the creation of a new process running as another user. Okay, you specify credentials from another user and you can create a new process with that security context. Okay, the default execution of runas is going to verify the provided credentials. Okay, so that means that the computer must know how to handle authentication for the user you want to kind of impersonate. Okay, here is an example. We are running runas as Vegeta and we want to create a new process as Bulma DA. So yeah, we run this command, we specify credentials, enter the password for Bulma DA, and we get a new CMD with the context of Bulma DA. But what happens when we try to create a new process with valid credentials, but from a user or an account that is not known by the current system or that has restricted access to the current system? Examples like I have credentials for a local user from another system and I want to create a new process with those credentials, or a domain user from an untrusted domain. So in those cases, runas is going to fail, the default execution of runas. For those cases, there is the Netonly Flag. Runas provides this flag to essentially allow this scenario described in the previous slide. So this flag tells runas that the credentials you are specifying are just for remote access. And for that reason, they are not going to be verified by LSA. So you must watch out when using runas Netonly because you can specify wrong credentials and you will still have a new process. So the funny thing, or the key thing here, is that a process created with runas Netonly is going to have two different security contexts. At the local level, the process is going to run with the original identity, so as Vegeta. But on the network level, the process is going to run with the identity of the credentials you have provided, Bulma. All right? An example here, run as Bulma DA Netonly, we specify the credentials, and when we run Who Am I, at the local level we are Vegeta, but if we try to execute a remote command on the domain controller with Bulma, Who Am I, with PowerShell remoting, we can see the result is Bulma DA. So locally we are Vegeta, whereas in the network we are Bulma DA. So what is runas Netonly doing? We have our original process running as Vegeta with the original token describing Vegeta security context and the original logon session with Vegeta's cached credentials. What run as Netonly is doing is it creates a new logon session with the credentials from Bulma. It duplicates the original token and updates the logon session identifier within that token. And that is applied to a new process. So what is happening here is that we have the original token, but the cached credentials associated to the logon session linked to that token are the ones from Bulma. Okay, so here we have an example. In fact, I'm going to do a quick demo of this. So we are Vegeta, and we are going to create run as Netonly user capsule.corp Bulma DA, and we want to create a CMD process. Okay, so here it doesn't matter the password I specify. In fact, I'm going to specify a wrong one, but you can see here there is a new process. Okay, if we run process hacker and we browse to that CMD process, when we check the token information, it reflects information about Vegeta, because run as Netonly is using the same token as before, the original token. However, if we run Mimikatz, privilege debug, could let's say passwords, and we find Bulma, we can see here a logon session, which is the one that run as created. The logon session type is new credentials. We are going to talk about this later on. And we can see the logon session is associated to Vegeta SA. However, when we check credentials, cached credentials from this logon session, we can spot Bulma DA and, well, the entity has, and here in Kerberos we can see the password I specified, which is a wrong password. Okay, so of course, if we try to use this process to PowerShell, invoke command computer name DC01 script block mi, this is going to fail. But if we do the same but specifying credentials, valid credentials for Bulma, now it should work fine. Invoke command, and we are Bulma in the network. Okay, so what is happening under the hood? Windows has one function called create process with logon. Okay, this function, I'm going to create process with logon. So creates a new process and its primary thread. Then the new process runs the specified executable file in the security context of the specified credentials. So you can specify a domain, username, and password, and this function is going to create the application as with the security context of that user. Okay, it's important to note that we have a logon flags parameter where if you specify logon with profile, it's going to be like an interactive authentication, okay? Like run as without Netonly. And logon net credentials only is like run as Netonly. So logon net credentials only, logon, but use the specified credentials on the network only. The new process uses the same token as the caller, but the system creates a new logon session within LSA, and the process uses the specified credentials as the default credentials. So yeah, run as is very interesting. But of course, running run as is not like the best experience as an offensive security attacker or whatever you want to call it. So running runners through a reverse shell or in general running runners is a nightmare. Okay, if we want to be stealthy, for example, and we want to avoid specifying command line arguments, then with runners we cannot avoid that. Okay, but we can implement our own version of runners. For example, Metasploit has a module which uses create process with logon and doesn't have the limitations of runners.exe. So yeah, with this module we can create the process and without leaking all the parameters, and yeah, well, it's like a better option. And I want to show, hold on a second, run as Metasploit. So this is the module, and if we scroll down, use custom command, sorry, it's not this one, run as this one, yes. So here we can see create process with logon is used under the hood, of course. Well, in the case of Metasploit, it has logon with profile hard-coded. So when you use this module, it's going to be like the run as the default run as execution. But it's, if you want to use a run as Netonly execution with this module, it's as easy as modifying the module and reloading it. Okay, so I don't have any session right now. Let's see this quickly. Let's get a session. Okay, session 7. So we can specify set cmd and the command to execute. I just want to execute cmd. The main, which is capsule.corp, password, session 7, and user volma.da. So if we run PID 4624 4624. So our stager.exe is running as Vegeta, but the child process is running as Bulma with this module. Okay, and as I said, we can either modify the module with the option to run like Netonly, a run as Netonly, or we can just go straight forward and use the IRV cell. And since we are just using one WinAPI function, we can use Railgun. Railgun, create process with logon. We can specify all the stuff, including the logon net credentials only. Okay. So now I believe the PID was this one, 184. But we will see here, yes, 184. So this one has the token reflects information about Vegeta, but again, in fact, what we can do is exit. We want to try listing the DC01. We can't, but we can steal token 184, which is a Vegeta process. Remember, the token steal token is going to say that we are stealing a token from Vegeta, and getUID is going to say we are Vegeta. But if we try to list, now it works. Okay. So interesting approaches. We can use this module. I mean, we can upload a new Meterpreter executable, and we can use this module to execute it as another user. Or we can do what we have just done. We can create an arbitrary process with Netonly, for example, and steal the token to acquire the desired security context. And a final option could be creating, like doing point 2, but instead of stealing the token, we could inject our payload into that process to acquire the security context. Okay. So yeah, create process with logon is very nice, but there is one function that is even better, because create process with logon, as the name implies, you need to create a process, but logon user is another function, and you don't have to create a process if you don't want to. Okay, in fact, create process with logon uses logon user under the hood, okay, to create a new logon session, right? So with logon user, we can create a new pair of logon session token, as I said, without creating a new process. And we can select the behavior of Netonly or not. Here again, okay? This functionality, the logon user functionality, is often implemented in commands from frameworks like Cobalt Strike or others with the make token command, okay? So the thing here is we can use this function to create a new logon session and then impersonate a new logon session and a token, and then impersonate the created token without creating any new process, and then we will acquire the security context just with that. And that is exactly what make token does. Clone the current access token and set it up to pass the specified username and password when you interact with network resources. This command does not validate the credentials you provide, and it has no effect on local actions. So logon user, we specify username, domain, password, and then the logon type. And in logon type, if you remember when we ran Mimikatz, it showed new credentials for the run as Netonly. I don't, yes. So for the run as Netonly process, the new logon session was specified as new credentials, okay, because run as Netonly under the hood uses logon user with the new credentials logon type. So yeah, if you run this function and in the logon type just specify logon new credentials, then this logon type allows the caller to clone its current token and specify new credentials for outbound connections, for remote connections. The new logon session has the same local identifier, but uses different credentials for other network connections. Okay? And you cannot, oh, I didn't know this. You cannot use it with GMSA accounts. Interesting. Okay, so finally we will talk about a few nodes because as you remember, well, yeah, let's just see these slides. So a few nodes. If you have a high integrity administrative context, we know manipulating tokens is easy because you can do everything. You can steal any token from other users, you can inject into any process, you can apply a stolen token in your current process, and you can also create new processes with a stolen token. Okay, but that is not I mean, if you have a low privilege context, a medium integrity context, you are not going to be able to do all the previous stuff. Okay, so you can only play with your own stuff, with your own processes and your own tokens. Okay, and that also includes processes created with runas, even if they run with an alternate security context, because Windows treats those processes as your own. So you can steal tokens, you can do process injection in your own processes. The second one is that you can impersonate a token in your current process, okay? And that doesn't require any privileges, as long as, of course, you can access the target token. So we have seen with this last demo that if we create a process with logon as Bulma, that process is going to be treated as our process, so we can steal its token and we can use it to interact or to acquire the security context of Bulma. So for our current process, it's okay, but creating a new process with a token requires privileges. So here, when we do sell, or better, when we do execute has a flag here, execute process with currently impersonated threat token. So when we do T and cmd.exe and c, f cmd.exe, so this is very similar to running the sell command. Okay, we are Vegeta. We are Vegeta, but if we do DC01 in the network, we are Bulma. So the token we have stolen, we did steal, it's been used in this new process. We can do this because we are in a high integrity context. Get briefs, we have a lot of briefs. it's slow again. Okay, we have a lot of privs. Okay, but what happens if we don't have a high integrity context? So let's get a new session. Session number 8. Get UID, get privs. We don't have any important privilege right now. So we can go ahead and do a run as, set session 8, and create a new process as Bulma. Okay, sessions 8. So if we steal the token, even if we are in a medium integrity context, we are going to be able to steal the token, okay? Because as I said, you can see this process. As I said, the processes created with create process with logon are treated like your own processes. Okay, so as you can see, this worked, and we can run get UID, and everything seems to work fine, although a bit slow. Not sure why. Okay, and if we do a ls, it's working perfectly fine. But then we run cell, and we spot this fail to spawn cell with threat impersonation, retrain without it, and we specify who am I. Oh, we are Vegeta. So that's why, because functions that use a token to create a new process require privileges. Sorry. For example, create process as user. The process that calls the create process as user function must have this increase quota name privilege and may require this assigned primary token name privilege. Okay, and these are high integrity privileges. And also we have create process with logon, which also shows create process with logon, no, create process with token. Create process with token. So this one is another one. We can specify a token to create a new process, but again, the process that calls create process with token must have this say impersonate name, which is a high integrity privilege. The only one that doesn't require privileges and allows you to create a process with another security context is create process with logon. But of course you need credentials. So yeah, if you are impersonating tokens from an unprivileged context, focus on inline execution. Focus on things that don't create new processes. Because if you create a new process, it's not going to have the security context you have stolen.